Hello guys, welcome back to my channel, Memo African Motives. Still working on mathematics for N4. That is in this platform we shall actually be working on the question paper which was written in February 2022, so that we can see how the questions were being given and how we are supposed to answer these questions. So in this platform we are just going to focus with the first question that we were given. So I want us to just make a closer look on the first question, that is which was on derivatives. Everything there was under derivatives. So what we are given in this case is the first question, that is question number 1 with 20 marks. As you can see, each and every question was having actually 20 marks, as we can see. So we shall be actually working with these questions separately. So for you not to miss these classes, make sure that you become part of the family Memo African Motives by subscribing, so that you won't miss any of the classes that we shall be having. So we shall quickly rush through the question paper that we are having. The first question on 1.1, we were being asked to differentiate y is equal to log square root of 3x. But on this condition, we are given by using function of a function or chain rule. So that is the question that we have, and we've got 5 marks for that. All right, so the first thing that we know is that whenever you are applying chain rule, you are given this part on your formula sheet: dy dx is equal to dy du times du dx. This is the formula that you're going to use when you're applying chain rule or function of a function. So the formula states that dy dx is equivalent to dy du by du dx. So now what you actually need, guys, is to find a derivative of y with respect to u, a derivative of u with respect to x. So how is this going to happen? All right, this is what you're going to do. From the log that we are given, which is square root of 3x, we can rewrite this, guys, as remember, square root from your exponents means to the exponent of a half, like this. So if it is square root of 3x like this, it means we have got log 3x everything like this to the exponent of a half. That is what we have there. So what can we do? From our laws of logarithms, we know that p log m is equivalent to log m to the exponent of p, which means we can drop the exponent. If you are given the exponent, you can write the exponent here now, multiplying the logarithm. So this is the condition that is happening. So you can be able to drop this exponent. So it's going to be y is equal to half log 3x, like this. So now we can apply the concept now of function of a function. So how are we going to apply our function of a function? All right, this is the concept, guys. You are going to choose the u, because definitely here you need a derivative of u with respect to x. So you're going to choose your u to be an expression or a term in terms of x. And which expression is in terms of x? This is the expression that is in terms of x, which is 3x. So your u is going to be 3x, an expression that is in terms of x. Then y is going to be an expression in terms of u. So which means in order for this y to be written in terms of u, what am I going to do? I'm going to substitute in place of 3x, I'm going to replace with u, so that this expression now is going to be written as y is equal to half log u, like this, so that you can obtain a derivative of u with respect to x, a derivative of y with respect to u, just like what we are given on the formula here. So let's do it, guys. How are we going to find this derivative? Okay, so we need the derivative of u with respect to x, which is in this case we are going to have 3x. Then we've got dy du. Take note, guys, we are finding the derivative of a log. This is a log. All right, There are so many ways that you can use to find a derivative of a log that is from the normal function, but this is the one that I'm going to show you that I prefer most. If you are given that y is equal to log f of x like this in base 10, like this one is log u, so which means we are in base 10 like this. If the base is not given, it means you are in base what? In base 10. So dy dx, which is a derivative for this one, is going to give you the first derivative of the function, which is the first derivative of f of x like this, over ln 10 times f of x. So you can write it as f of x like this by ln 10. This is the derivative of a given log in this format. That is how you're going to express it. Y is equal to log f of x in base 10. That is the derivative. So now in this case, we want to find the derivative of this log u base 10. So half is just a constant multiplying, so you're just going to write as it is. Then if you are to cross check here, the derivative says the derivative of f of, which means the function that you are given here. Our function is u. So what is the derivative of u? If you differentiate u, guys, you're just going to obtain a 1, because just like what we did on 3x, we took 3. So this one is u, same as 1u. So you're going to take 1 over f of x ln 10. Your f of x in this case, you're referring to f of u, this function of u. So u is going to remain as it is. So it's going to be u times ln 10 like this. So you're going to have u ln 10. This is what you're going to have. So which means I can multiply this together, 1 times 1, which is a 1, then 2 times u. Take note, this is u. So 2 times u, that's 2u ln 10. This is what you're going to have. So it's going to be 2u ln 10. That is what you're supposed to write, guys. Take note. So in this case now, I have my dy du, I have my dy dx. These are the two that I'm having. So what am I going to do with these? I can actually substitute now into the major formula that we had here. Sorry, I'm having it here. This is the one that we wrote here. So now dy dx. So I'm going to explain another step again. Dy du. Okay, this is our dy du in this case, which is this part here. So you're going to substitute now dy du, which is 1 over 2 u ln 10. All right, so you're going to have 1 over 2 u ln 10. This is what you're going to have multiplied by du dx. All right, our du dx, we obtained 3. So you're going to multiply by 3. So this is what you're going to have. But if we are to cross check now, this is dy dx, which means it's a derivative of y with respect to x. So which means we must have an expression here of what? Of x, not this u, because it's with respect to x, but here we have got a u. So what are you going to do with this u? We are going to substitute back this part where we said let u be equal to 3x. So if we said let u be equal to 3x, that means I can substitute this u now, which is equal to 3x, into this u here. So it's going to be 2 times 3x like this, because this is 2u, 2 times u. So 2 times 3x, which is 6x. So therefore, dy dx in this case is going to be 1 over that 2u now that we multiplied and obtained 6x. So it's going to be 6x ln 10. All right, here we can also multiply 3 times 1, because this is 1 is same as 3 over 1. So 3 times 1, that's 3. You can combine instead of writing it aside. You can combine. Then someone can reduce this 3 into 3, that's 1 over 2x like this ln 10. So take note, you can divide 3 and what? 3 and 6. From your calculator, guys, 3 over 6 like this, 3 over 6, you're going to obtain 1 over 2. So it's going to be 1 over 2x ln 10 like that. Okay, so like I said, someone can have the derivative of a log in a different manner, but that is what you're supposed to have, guys, for this one. This is the concept that you can take in an easier way, So what is important is this part that I explained here. When you find a derivative of a log of f of x in base 10, divide x is the first derivative of the function that you're given here over the function as it is, which is f of x. So here, let me just write it here. Maybe you can understand me much better, because I said divide x of a log is going to give you something like this. So let me explain from this formula by ln 10. So this is the derivative of that function. So you're going to find the derivative here of f of x. Okay, then this one you rewrite f of x. So you rewrite f of x as it is. Then this one is now a natural log from the natural log, because we are in base 10. So that is why we are going to have ln 10. So this is where y is equal to log f of x, like this, in base 10. That is what is going to be your divide x. And whenever the base is not given, if you are given log 3x base 10 like this, it's the same as just writing it as log 3x. So one and the same thing. Base given, not given is the same. If the base is not given, it means you are in base 10. Any other base you will be given is at base 5 or whatever that you will be given the base. All right. So that's what we actually had on the first question. Then on 1.2, still on derivatives again, that is what we had, and we want to differentiate that again. So this one, we are not like applying the same thing. Now it's a different question, but we have to find divide x. So in this case, it's best for you to actually simplify each and every term separately. So this part here is fine and this part is fine, but here on this part, that is where we have to work this part. Okay, so I'm just going to rewrite this first two, because there's nothing that we can do there. So y is equal to 3 by 7 to the exponent of 2x plus 5 log x. So these ones, they are fine. All right, but this part here now is the one that we want to work on. So take note, there's a minus here. So I'm going to put this minus, which means it is going to subtract whatever that we are going to obtain from this part here. Take note, it is going to subtract whatever you're going to obtain from this part. So let's simplify that part aside and see what we are going to have. All right, so I'm just going to write this aside. We have given cos 2x plus 3 tan x, because we can't differentiate this direct. That is why we have to simplify it first. All right, this is the part that we just want to talk about for the meantime. All right, what can we do, guys, here? Okay, we can separate this, because we know that a plus b over c, like this, can be written as a over c plus b over c. It's one and the same thing. If this is affecting these two, you can separate the two. So that is what you're going to do here. Cos 2x over 2 sine x. I have separated this, plus I move on to this one, is 3 tan x over 2 sine x. I have separated this, but still we do not have anything that is exact, that is in exact form, that we can actually use in this case. So what are we going to do again? This is the question. So we have to simplify again separately. So let's start with cos 2x. Cos 2x, I want you to see that here you do not have the identity that replaces cos 2x. So I want you to be very, very clear about this one, so that in exam you know that you are not given. But you have got 3 identities that you can use for this cos 2x. So I'm just going to take them so that I'll show you which one am I going to use. Cos 2x is equivalent to cos squared x minus sine squared x, also equivalent to 2 cos squared x minus 1, also equivalent to 1 minus 2 sine squared x. So these are the three identities that we have, and of these three, which one can I choose? Take note, guys, here in the denominator we've got a sign, so it's best for you to choose this identity which only have sign, because this one is got cos, this one is got cos and sine, but here in the denominator we only have sign, so it's best for you to choose this one with a sign. Okay, so I'm going to separate this as 1 minus 2 sine squared x everything over 2 sine x. This is what you're going to have, plus, what about this part here? All right, here we are dividing, but how can we simplify? We know that tan is equivalent to sine over cos, so you're going to have sine x over cos x, so it's 3 times sine x over cos x like this, which is going to divide 2 sine x like this. All right, but here we are now back to the same thing again, because we are given another fraction again, and these are two fractions, so we're going to separate just like what we did here. So we're going to separate also here, so we're going to have 1 over 2 sine x minus 2 sine squared x over 2 sine x. We are now separating this. So by separating, what are we going to have? We can simplify. Okay, let's just write here plus. What about here? What can we do? The only thing that we can do, guys, is to cancel this, because it's in the denominator, in the numerator, so we've got the power to cancel the 2, so you're going to be left with 1 over cos x, so it's going to be 3 over 2, but remember from your identities, 1 over cos x is equivalent to sec x, so you're going to obtain 3 over 2 sec x. All right, but here we talked about something that you are supposed to be simplified, 1 over 2, but we have got 1 over sine. What are you going to obtain from 1 over sine? 1 over sine gives you cosec, so 1 over sine is cosec x. Then 2 and 2 can cancel. We have got sine squared and sine, so you can cancel this to give us minus sine x, so this is what you're going to have. Then here we've got plus 3 over 2 sec x. So guys, take note, this is what we are obtaining. This is the part that we are obtaining from this given identity that we had. But what are we supposed to do now? Because this is the part that of just simplifying the trig. We are supposed to replace it back here, because remember, this was a question that we're supposed to subtract here. So you're going to subtract this part that we obtained here. So minus times, because your minus is going to affect everything, so it's minus times this, so it's going to be minus half cosec like this x. Okay, then minus times minus sine, so there's a minus, so this minus is affecting everything, so it's minus and minus, which is plus sine x. Okay, the minus that we had times a plus this one, so it's going to be minus, this minus is going to multiply everything. All right, so this is what you're going to have. Take note, guys, we had this question here. Let me show you again. This was the question. The minus here is affecting this whole trig, so that is why this minus is now multiplying everything that you obtained from that trig. And take note, we were just rewriting the expression here. So now we are going to find our divide x. So what is going to be our divide x? So divide x, we're going to find the derivative of the first part. So finding the derivative of the first part, we know that when you are given to the exponent here, this is the part that you're going to use ka to the exponent of x, which is going to be ka to the exponent of x ln a. But take note, this time there is a number that is affecting here, which is 2. So this 2 is supposed to multiply, to find the first derivative of 2x, you multiply it to 3. So the first derivative of 2x is 2. That's the first derivative. So because you're supposed to have your formula like this, first derivative of x is what you're going to have. So you're going to have k, first derivative of x, then a to the exponent of f of x like this, ln a. This is supposed to be your dy dx like this. When there is a function of x here, which is not a straight x, both you're given like x there, or you're given a condition like 2x. So when you're given something like 2x, you have to find the derivative and multiply it to the constant. So that is the case here. So it's 2 times 3, which is 6. Then this part is going to remain as it is. So here we've multiplied these two, a to the exponent of f of x, which is this part here, 7 to the exponent of 2x, ln a. This is your a, so it's going to be ln 7. All right, plus we have got a log again. Remember, I talked about this log, how you're going to find the derivative of a log. We said if you're given a log, it's going to be first derivative over f of x ln 10. So this is what you're going to have. So the first derivative of x we are given, this is x. So the first derivative of x is what? It's 1 over f of x. Our f of x in this case is x. So it's going to be x ln 10. But take note, there is a number which is outside 5, which must multiply this. So it's going to be 5 times 1, which is 5. So you're going to have plus 5 over x ln 10. So this is what you're going to have. Take note, guys, how you multiply a whole number to a fraction, same as 5 over 1 times 1 over. That's how you multiply a whole number to a fraction. We move on. We've got cosec. Okay, the derivative of cosec, you also have it here. Cosec is going to give us minus cosec x cot x. So take note, it's minus there, but we already have a minus. So this minus on the formula here, and this minus is going to give us a plus. So it's going to be plus half. Remember, cosec gives us cosec and cot. So it's going to be cosec x. That's cosec x here, cot x. So that's the idea. You move on to sine. So take note, sine is cos. So it's a plus this one, plus cos x plus cos x. All right, we move on to minus 3 over 2 sec x. All right, so where do we have sec? Sec is sec tan. There's a plus, so this plus and a minus, there's no effect, so it's going to remain as a minus. So it's going to be minus 3 over 2 sec x tan x like this. So this is what you're going to have. So this is a continuation, guys, to this part. You're going to continue with this part. That is going to be the derivative there that you are given. So take note about this question here, what we're supposed to have, and the application of the sign, and to correct all the steps which are not given in a proper way, because there was a minus. The minus there is the one that affected all the signs, because this minus was affecting the whole trig. So that is why you have to multiply everything that you obtained by a minus. So take note about that. If we don't multiply by that minus, it means it has no effect, but that minus has got an effect which is supposed to apply to be applied properly then. Okay, then now on the applications now of the derivatives on 1.3, these are applications of derivatives where we can be asked to determine the maximum and the minimum turning points. So by using or with the aid of differentiation, you want to find what? Maximum and minimum turning points. And to distinguish between the maximum and minimum turning points by using second derivatives as well as the points of inflection. So we've got 3 questions from this question. We've got 3 questions which are there. All right, so the first question is to just determine the maximum and minimum turning points. Okay, so using the applications of derivatives, we all understand that for you to find the maximum and minimum turning point, it's on a condition that the first derivative should be equal to 0. So that is what we have here. At any turning point, that you can talk about, the first derivative, which is dy dx, should be equal to 0. So if this is the concept, or if this is the case, therefore, let's find the first derivative here, because we are given y with respect to x. So this is what you're going to have, dy dx, because we are given y. So we are just going to find our dy dx in this case. All right, I wanted to find the value, to write the value of y, sorry. Let's just write our y as it was. All right, now we want to find our dy dx there. So what are we going to have in this case? These are now no more derivatives, you know, that drop the exponent, then subtract 1. So it's 3x to the exponent of 2. Minus, we multiply 4 and 2, that's 2 by 4, which is 8. We subtract 1, so it's 8x plus a 4. So this is what you're going to have. So you're going to be left with 3x squared minus 8x plus 4. So now, since we are calculating the turning points, that's where I'm saying we have to equate this first derivative here to 0. All right, so that is what you're going to do. So which means this part here, 3x squared minus 8x plus 4 is equal to 0. So by doing this, we have formulated an equation, which is a quadratic equation that you can solve depending with which method is best for you. You can use a factorization, you can use the quadratic formula, so you choose the one that is best for you. So using the quadratic formula, you know that x is equal to minus b. We have got a, b, c. So it's minus b, which is minus 8, plus or minus the square root of b squared. So this is our b squared, which is minus 8 squared minus 4ac. So this is 3 times 4 over 2 times a, which is 2 times 3. So you can use the quadratic formula, or you can use factorization. So you choose the one that is best for you. So for those who are going to use factorization, you're going to obtain the same answer as the ones that you're going to obtain here. So from this one, applying your quadratic formula at once, the value of x is going to be 2, or another value of x is going to be 2 over 3. So these are turning points, guys, that you're talking about, not the values of x. We are talking about a turning point. So you've got two possible solutions. So you can actually name these possible solutions, that let maybe this be x1 and be x2, so that I can determine the corresponding values of y to give us a turning point now. So let's start with the first value of x1. When x1 is 2, which means we can find y1. So where are we going to find the value of y? We're going to substitute x into this expression of y. So you write as it is, you substitute as it is. It's a point that is supposed to be indicated there. All right, so you have got 2, because you're substituting 2 here. So it's 2 to the exponent as it is here, the exponent of 3x, minus 4 by 2 to the exponent of 2 plus 4 into 2, like this. So you just substitute in place of x, you're substituting 2. So simplifying this, you're going to obtain a 0 there if you do this properly. So that's now a point 2, 0. Remember, a point is written in terms of x and y like that. So that's a point. So we do the same here for x2 when it was 2 over 3. What is the value of y there? So you're just going to substitute again in place of x, substitute 2 over 3. So you've got 2 over 3 to the exponent of 3 minus 4. That's going to give us 2 over 3 to the exponent of 2 then, plus 4 into 2 over 3. So you're supposed to indicate like all these stages. It's not like they are not important. They're very, very important. So this is what you're going to obtain here as your y2. So the most important part is writing this as a point. So we are going to have Here we've got a 2 over 3, the value of x, and the value of y, so it's going to be 2 over 3, 32 over 27, like this. All right. So my main focus here is knowing our turning points now, because this is the first turning point. So you can just if this is the turning point 1, and this is the second turning point. All right. So now the question is, we are supposed to state now that to distinguish these two turning points, we are supposed to distinguish this part. All right. So how am I gonna distinguish this part that we are given here? All right. So this is the case. From the concept that we know from the second derivative, because we are going to apply the second derivative here, we know that to obtain a turning point, its condition, it is going to be according to the value that we are going to obtain from the second derivative. All right, this is our first derivative that we have here. So meaning to say the second derivative, we're just going to have a continuation from this, which is now 3 by 2 by 3, which is 6. So it's going to be 6x in this case. So we're going to obtain 6x. Here I've got minus 8x, which is going to just give us minus 8, and plus 4, it's a 0. There was a constant, so we're going to obtain minus 8. So having this is not much important, but knowing what you're going to do on this expression is the one that is important here. So in order for you to know that this point is a maximum point, turning point, or this point is a minimum turning point, you are going to substitute the value of x here onto the expression that you're given. Why? Because we know that if the second derivative like this is greater than 0, when you're talking about positive values there, that is positive values, it means you are referring to a condition where you are given the minimum turning point. If this second derivative with respect to x in this case is less than 0, which means you're talking about a condition where you are working with negative values, which means that's a maximum turning point that you're talking about. So that is the idea, that why we have to substitute the value of x, because we need to know, is it less than 0, or we are not equating to 0. We are comparing to 0. It's a comparison that is taking place. So let's substitute and see what you're going to have. The first part here. All right, so for the first value that we had, it was 2. The x1 that we had, it was 2. So you're going to substitute 2 here. So 6 by 2 minus 8, which is going to give us a positive 4. This one is going to give us positive 4 from x1. From x2, we are going to have 6 into 2 over 3 minus 8. All right, which is going to give us minus 4. All right. So from this part that we are given, now what is our turning point? What is the nature? These were the turning points here. This was the first turning point. This was the second turning point. So from this comparison that we did here, from x1, it means the first turning point, which is 2, 0 in this case. Since this is a positive, and we are referring to this part, when it is a positive, that's a minimum turning point. So it means this point 20 is a minimum, that's minimum turning point. So that's what you're having there. From x2, which is the second turning point, this is where we substituted our x2. The second turning point was 2 over 3 and 32 over 27. But because of the second derivative, we obtained a negative, and we said whenever it is a negative from the second derivative, that is when it is less than 0, it means that's a maximum turning point. So it means this point here, this is the point that you're talking about, is a maximum turning point. So this one is a maximum and this one is a minimum. So that's how you use derivatives, second derivative, to determine that this is a maximum turning point or this is a minimum turning point. You work with the derivative, the second derivative. When it is a positive, it's a minimum. When it is a negative, it's a maximum. So that's the idea. So you can actually find these by derivatives. Then the other part that we're given now is by using the second derivatives as well as the points of inflection, which means we also need to find the points of inflection there, the points of inflection. So where are we going to find the points of inflection? Okay, so for the point of inflection, this one is direct. We are going to have a continuation from the second derivative. Okay, so this is point of inflection. So the point of inflection is taken from the second derivative, but this time you are equating the second derivative to 0. So that's the point of inflection, when the second derivative is equal to 0. The turning points are at a condition when the first derivative is equal to 0, but the points of inflection are at a condition where the second derivative is equal to 0. So we got our second derivative before, so it's a continuation, 6x minus 8, that was our second derivative. So this time we are equating this to 0. Take note, there is no sign. This time here it's not equal to 0. We are saying it's greater than, or we are talking about a condition where it's less than, not a condition when it is equal to 0. I hope we understand this part. It's only equal to 0. So it's only equal to 0 when we are talking about the points of inflection. So that's an equation which needs to be solved for x. So 6x is equivalent to positive 8. So divide by 6 by 6. So x is going to be 4 over 3. So just like the previous part, guys, our points of inflection is going to be, you take the value of x, which is 4 over 3. Remember, everything that is referred as a point has to be x and y. So where are we going to find the value of y? We use the normal equation that we're given here. Remember our normal equation, y is equal to, in place of x, you're going to substitute 4 over 3 throughout. In place of x, 4 over 3. So you're going to obtain a value of 16 over 27. So this is what you're going to have as the point of inflection. So it's actually 4 over 3, 16 over 27. So that's what we had on this question. Then let's see another question also, which was the last question on limits. Calculate limit. Okay, that's the limit that you're given. Let's see how we're supposed to calculate this limit, guys. It's limit, that's limit x is approaching to 2. Okay, but we're given x squared minus 4 over 3x minus 6. That's a limit that you're given, but as x is going to approach to 2, like so, a condition where x is approaching to 2, we are simply saying we have to substitute the value of x, which is 2. But now in this condition it's impossible, because if x approaches to 2, you're going to see that the denominator is going to give us a 0 here. So there is no condition where the denominator should be equal to 0. That part does not exist in maths. The denominator can never be equal to 0. So which means we're supposed to at least simplify this expression before applying the limit when x is going to approach to 2. So how are we going to apply the limit? We just test what we can do here, guys. Let's test. What can we do? We've got x squared minus 4. Let's try and factorize and see. All right, limit. That's a difference of 2 squares for me. x and 4 here. So we've got x plus 2, x minus 2. Remember your difference of two squares when you are working with the square roots, because these are perfect squares, x and 4. So x square root of 4, that's a 2. Then here you've got something that is common, which is 3. So you're going to be left with x minus 2. Taking this into consideration that we can actually cancel these two, x minus 2 can cancel, which means we are left with this part now. So it can be applicable. This is not E0 but 2. I'm now thinking of derivatives. This is just 2 there. So now we can apply this limit in place of x to say when x is going to approach to 2, because we are just left with something like this. Or let me just write it separately so that we can see what I'm talking about here. We are given something like over 3 like this. X is approaching to 2. So as you can see, the denominator can never be equal to 0 now, because already we are given a whole number, which is 3. So now we can apply the limits to say x is going to approach to 2. So it's going to be 2 plus 2, which is 4 over 3. So that is going to be the final answer for the limit that we are given. So that's how they can ask these questions on limits, knowing that we can apply the limit direct, which is wrong. So you're supposed to at least simplify into a manner that you understand much better. So guys, that's it from Mezon African Motives, working on derivatives from the question paper which was written in February 2022. So we shall meet again while we shall be working on integration on our next class from the same question paper, but now on integration. So not to miss, make sure that you become part of the family, Mezon African Motives.